tempo.
All right. So welcome everyone to another live stream. Hopefully everything is working well. I'm always a little bit nervous starting these that I forget to unmute myself or something along those lines. So please let me know in chat if there's any problems with the stream. Right now you should just see my face and a little bit of a background. And I'm going to spend just a few seconds here kind of setting up the content for today and really laying out a little bit of the history here in terms of these episodes, because I'm calling them episodes. I don't know how else to refer to them, but episode 5 here. So that does imply a little bit of a sequential nature. Outside of that, we'll get into the demo. We're talking about Capa today, a capabilities extraction tool from the Flare team. It's available on GitHub, and today's focus is really just a basic introduction. So how you can start to use it, understand the tool, the value that it'll provide you in performing your analysis and extracting content, or capabilities, really. Of course, that's what it's named for, from the malware that you're investigating. There could be, and likely will, I can see a lot of potential additional videos, maybe even live streams that cover, we'll talk about the rules in Capa. That could be a whole live stream or a video. Integration with tools like MITRE and IDA as well. So a lot of opportunities here. I really just wanted to use these first episodes, as you'll see throughout the history of the different Malware Mondays, to start with the basics and to kind of set some baseline tools and even some techniques, as we move through these, and how many we'll do, I don't know. When we'll deviate or get into some of the more advanced topics or techniques, I don't know, but I do plan on doing that at some point in time here. We're just going to keep going, and any feedback that y'all are willing to provide me in in the content and in the direction, I appreciate that, and I'll use that to really determine where to go next. If you look at the website, cyberyeti.com/Malware Mondays, you'll find, I think that's it. You'll search for it, you'll find it. You get to the website, you'll find it. If you go back to the previous, a lot of the samples, there's one main sample that I've just been using over and over. It seems kind of drawn out, but I'm using that sample to kind of baseline the tools and the analysis techniques, and then throwing additional samples in as we go. Some custom programs, some will just be capture artifacts like network traffic and process monitor logs and other things that are relevant to maybe the tools that we're utilizing. With that build up, so the idea is you could go back and start with the first one and kind of work your way through, and you'd see kind of the continuity. But also, if you just want to look at or learn a specific tool or technique, then also the videos are meant to be standalone in that regard as well. So with that being said, let's go ahead. Let's move into... Before we get too far, I did want to take a moment and announce that my latest Pluralsight course is now live. I've been doing a little bit of promotion here on social media. It's Assembly Basics, and this is part of a malware skills path. In my mind, the kind of tools and techniques that we're covering in these Malware Mondays are kind of to the left of the reverse engineering curve. That is, there are reverse engineering concepts, but you don't need to get into MITRE IDA in order to perform the malware analysis techniques that we're covering here. And then eventually, as you get deeper and deeper into needing to maybe get more concrete answers, or understand more about a particular sample, oftentimes the final payloads become executable files, PE files. You have to get into reverse engineering. And so you kind of reach this point where using those tools and learning assembly becomes quite essential. And so that's where this fits in that learning path. I think it's a great primer. It's also a great refresher if it's been a while. It's very condensed. I tried to cram everything down into an hour. I didn't quite make that. I think it's an hour 28. There it is, hour 28. There's just a lot here to help you get started, and also to provide sort of a mechanism for you to continue to learn. I'm not possibly going to be able to cover every single technique, every single instruction, every single nuance when it comes to reversing and the assembly language as it relates to that. But hopefully this will set a pattern of you being able to then kind of continue on your own. And I do that by doing a lot of what you see in my live streams and in the videos I produce, taking samples that are, we write in C, we compile them, and then we disassemble them with a tool to analyze that, because that's typically what you're going to see when you're encountering malware out there in the wild. So anyways, if you're interested in checking it out, let me know. I have some free trial codes to be happy to share with you. Just send me a DM on wherever you can find me, on the Discord, social media such as X. I'll be happy to help out there, and hope you enjoy the course. Let me know if you have any feedback as well. Okay, to get started then, we've got our tool here, Capa. And as I mentioned, not only is it freely available on GitHub, but it's also part of the Flare VM. So I'm using the Flare VM here for my analysis, as I usually use it for anything that I'm going to do Windows-based. You can take a look at, there's a number of blog posts here that introduce sort of the basic approach to Capa, as well as then some major updates along the way, supporting ELF files, supporting .NET, runtime behavior with Cape Sandbox. So some really great capabilities here. We're not going to be able to cover all of them. And we're going to just focus on that real basic and practical usage. We'll likely cover a little bit on the rules here. This is going to be a separate repository, Mandiant/Capa rules. These folders here provide sort of the namespace organization, and I'll connect the dots here in just a moment as we start looking at output. But these are where the rules reside if you want to look at what the rule logic, and I guess maybe I've gotten a little bit ahead of myself. Capa is going to use rules in order to give us the feature extraction, the capabilities. And so here are these rules. And so this is where if you really needed to understand 100% what a rule was, what its syntax, what is written, what its logic it contains, this is where we're going to go in order to do that. Of course, if you want to start writing your own Capa rules, this would maybe be a good place to go to not only look at existing rules, but there is some rule development documentation here. Let's see, I think I've got it linked. I'm not sure where it links to on that main page. It's there, but then here's this whole rules writing document. So it tells you not only the format, but like what does all of this stuff here in a potential rule actually mean? Do you need to know all of this to get started with the tool? No. And that's part of what I want to highlight today is we can just start using Capa, throwing in binaries at it and seeing what it tells us. So without further ado, let's go to a terminal. Capa, again, already installed, part of the Flare VM. So if you are not using the Flare VM, you can find the binaries, you can find install instructions back on the GitHub. We can just prompt it for help information. That's usually a good place to start, usually where I start, just to get example command line usage and what are the different flags or options here. As you can see, there are a few. There aren't too many. It's not overwhelming. And for this stream, we're going to probably just go with a lot of the defaults here. We are going to use the verbosity mode here, TECV and TECVV. So you'll see me use that in a bit. We have the file format. So we're going to then, the default mode is for auto. Capa will auto detect the type of file, but we'll use that here in a moment to prompt it for some shellcode. So I'm going to use a number of different samples just to show some variety in Capa's capabilities itself. That is the different file formats or lack thereof that it supports. You got some back-end engine. Capa is going to, in a nutshell, be able to take the binary, do some disassembly or decompilation in order to deeper understand what's happening in that binary. And that's how it's going to, in large part, be able to extract those capabilities. So when you run the tool, it takes a little bit of time, and that's why. Now, you'll also, kind of as a side thought here, we've talked quite a bit about obfuscation and packing and other forms that can be employed on an executable or just any file really for that matter. We're more interested in what Capa supports at this point in time. But if there's any sort of packing or something, that's going to affect the abilities to extract, Capa's ability to extract those capabilities. All right, so that's something to keep in mind, and I'll show you an example of that here in a little bit. We have our rules. Right, so these are going to be the default rules that are going to get pulled from that GitHub that you saw earlier. That's the core logic, right? That's the good stuff usually that we're looking for in terms of the output here. It has some signatures. These are going to be flirt. They're going to help with library detection. And so these are things, again, they're just kind of working behind the scenes that unless you really, I think, start getting into heavy Capa usage, you probably won't even know or appreciate that they're there. There is a tag option. We'll use that in a moment. The tag option will allow us to filter. as you can see here. This can be really helpful, especially if we get a lot of output, which I've got one sample that'll do that. And then we can emit JSON. We don't need to do that, but just know that is an option for other ingestion. Now, there are some Capa tools to integrate with IDA, I think with Ghidra as well. So that's, again, another opportunity for probably a live stream or a video here later in the year or just sometime in the future. Okay, along with this help output, we got examples of usage. This is also can be very helpful if you're new to a tool or you just forget, like, how do I do this thing? Yeah, here's almost a verbatim example that we'll use in just a little bit here to get shellcode. Some output information to show match locations. You'll see that in a moment. All feature match details. So that's the TAC VV. You'll also see that in a moment. And that's just an option here showing the filtering. All right, so just helpful. All right, let's get into a sample. So I've got a number of samples here that we're going to go through. I chose these because they have a variety. There's a number of different file formats, a number of different states of packed or unpacked. So the first one, simple. We've covered this in a previous, the XOR encryption. This was the strings video. If you're curious on a little bit more about this binary, I'll refer you back. I forget which episode it was like 3 or so, but you'll be able to easily find it off the website or on the the live stream playlist here talking about strings. Here we have a couple of strings, ASCII string, or a wide character string and ASCII string, and there is an XORed string along with an XOR decrypt encrypt loop. So, I would expect, Capa to be able to identify this in terms of the use of XOR encoding or XOR encryption. Now, obviously, we don't typically have the source code, right? When we're reverse engineering, we have the binary, it's the binary state. And the reason that Capa can be really helpful is because we oftentimes have a lot of code to analyze. And this can help to not only extract those potential capabilities, but then, as you'll see, kind of pinpoint where in the code those capabilities exist. So this is just one of those exceptions, I think, to help with the learning and to kind of correlate with some of the previous analysis that we've done, and just highlight some of the behaviors that you're about to see here. The main thing that this does is print strings, and to make it have just a slight element of realism, the mutex. All right, and it opens the mutex, and then if it doesn't exist, that means, or it assumes that it's not running on the system, so then it can create the mutex. Okay, so I've already compiled that. Let's just go Capa xor.exe, and we'll give it a second or two here in order to just start doing its work, doing its disassembly, and creating functions and detecting basic blocks and analyzing the file. As we look at rules a little bit here today, and if you get into the documentation, you'll see the scope. Like, where does what scope does the rule apply to? And there's like the very granular level, which is the instruction level, and then it kind of backs out from there to basic block, to function, to then even file. And default output, you're not worried about any of that information. Here we go. Here's our output. You can see we don't really have any real granular information about how the rule worked, how it detected, where it detected in this binary. We just know that it detected. So there's these malware behavior catalogs. If you're not familiar with that, there's a project, you can find it online, malware behavior catalog, and there's also a GitHub and a wiki and all that. So you can read about that. But essentially, it's just trying to work with a lot of the MITRE stuff, the attack framework, to help classify and organize. That's the main goal here. And so what you're seeing then is this classified and organized output to help with your identification. So here we have process, and the behavior is check mutex and create mutex. The capability then kind of a very similar, check mutex, create mutex, and then this is the namespace. So the reason I showed that rule repository early on was just so you could see, like, this is now how that namespace matches up. There is something under host interaction mutex, there's a rule that matched. So we could go back to, let's see here, this should be the repository. What was that again? Host interaction and mutex. So there should be a host interaction. There's the host interaction folder. I'll make that a little larger. And then there should be a mutex here. Right, and there's our rules. So that's great. Right, we know that there's some possible mutex capabilities in this binary. If we want to kind of dig a little bit deeper, then that's where we have the TAC V or -V. So we'll just add that as an argument, run against the same binary, and we'll see our results here. again, a few seconds to run, just as it's doing the disassembly. There is one other binary here that this inject.c, eject.exe. Let's see, I'll zoom in there for you. You can see those right there. Those are from, I think, the last live stream, and those just take a while, so I'm going to actually skip those. I plan to include them, but I've got enough samples here that I don't think they're worth including. It can take a little bit of time, is the main point. So if you're analyzing a binary, and Capa's just, it's got a lot of code to disassemble and analyze, sometimes it just takes a little bit. Here's our output. You can see up above, we got a little bit more information about just the total analysis that took place. And now we have our two capabilities, and then really the name of the rule, check mutex and create mutex, as well as the namespace that those exist in. So now we could go and look at, well, here's check mutex and here's create mutex. As you can see, the rules are in a YML or a YAML format. And here's the rule logic itself. So we're not going to spend time on the rule logic. Again, I think that's kind of worthy of its own stream or probably sequence of videos. But just to give you an idea of where those exist, if you want to start looking at those, or if you need to, we have match location information. So this is also helpful because this is going to tell us now where in the binary the match occurred. And you'll see that the scope I mentioned very briefly earlier, the scope is also going to help to understand where that match is occurring, how that match is occurring. And so this check mutex was a basic block scope, and it matched at this address 401040, where this scope was at the function, and it matched at the same location. And just to give you an idea, let's see, of what I'm actually referring to there, we can open this with IDA, and yeah. Here we go, and I'll just turn on the line prefixes. That'll give us, let's see, so 401040. You'll see that is right here. So not only is that the beginning of this basic block, we're in the graph view in IDA, so it makes it easy to identify these basic blocks. It's just a block. Essentially, they end with a conditional logic or a flow to another location. But this also is the beginning of the function. So it's at this point that the rule and the scope is a lot, identifying the location in the original binary. So we know with the first rule, it's the basic block. That kind of makes sense because there's the call to open mutex. Whereas in the second rule, it's the function. So the logic might be due to the two APIs here. We'd have to check the logic in order to ensure. Let's not spend too much time in IDA. Okay, the next level is TACVV, and we'll run this. Again, it'll take a few seconds just for the analysis to keep up. Let's see, question on YAR rules work with ARM7. I'm not sure offhand about YAR rules working with ARM7. I mean, YAR rules are fairly agnostic when it comes to what you apply them to. So it's really up to you to determine what the content is and then how to apply it to whatever. For example, if I was writing a YAR rule for binary that was written or compiled for Intel, like the byte sequences I would use to detect some code pattern, I would craft that in order to provide the relevance to the type of files that it was to apply against. So I don't see why you couldn't do that for other architectures. It's up to you then to write the sequences, and Yara is just going to take input files and match patterns against those based off of the rules that you write. So nothing's jumping out at me. I haven't tried it though. Maybe there's some catch or caveat that I'm not thinking of, but I think it's really just up to you. Okay, so here we have, let's go down here. You can see more verbose output, and now we're getting information about the matches themselves. So you can see the basic block, and then here's actually what matched. So this, again, this kind of helps us to drill a little bit further into the rule to understand what it's matching on, if we need to. As you saw, though, without running the verbosity, without worrying about what the rules are actually matching on, we're able still to just run it and extract those capabilities. So just wanted to show you that. Again, kind of avoiding getting too lost into the rule syntax because I'm trying to keep these I started these live streams thinking I could do them in 15, 20 minutes, pick a tool and then just focus on that and make it quick. But almost everyone goes for just about an hour. So I'm going to have to try to keep these somewhat limited and myself a little bit reined in. Okay, let's move on. Another sample. Let's see, shellcode. Okay, so this is the shellcode I used in the live stream with the Off by One channel. So that was just recent. So if you're interested in getting a more detailed analysis, you can check it out there. I also have an exercise on my GitHub, the malware samples repository, which has some analysis for the shellcode. We don't care about the inner workings at this point in terms of understanding the code ourselves. What we're going to do is use the SC32 with the -f argument. So that's going to define the file format. You can use help information to go back and see what potential options you have here. And then stage 1 shellcode.bin. Okay, so now this is analyzing the shellcode. Now this one's kind of interesting in my opinion because the entry point of the shellcode is at an offset into the file E5D. And I know that because I originally did the analysis to figure out where the shellcode was staged and where the entry point was executed. Capa doesn't provide an option to define that entry point. So it's going through and performing the analysis, and I would assume is just starting the disassembly process at the beginning of the blob. The shellcode itself, just to kind of confirm here for everyone that it is just a blob of code. Here is our hex editor view. As you can see, there are no file format information up above. It's just a chunk of binary code. That's what Capa then just analyzed for us. And it looked like it did a pretty good job of identifying a number of different capabilities. Let's see, we got check for PEB being debugged, contain obfuscated stack strings, 6 matches, encoded data using XOR, gets the number of processors, accesses the PEB loader data. So again, the output, this looks like there's a layer of obfuscation here, right? That's kind of my takeaway of this. There's a number of anti-analysis techniques, and maybe what's really interesting and happening in here is still obfuscated or hidden behind this layer of obfuscation. So that could be an opportunity then to go and dig into this binary a little bit more, a little bit deeper. What we can do is we can get a little bit more verbose output. Let's do -VV. And I want to just focus for a moment on the stack strings and just show you how this can help expedite analysis inside of something like IDA. And let's see if I can find those. Okay, so here we have our stack strings. Maybe this is a little too verbose. I mean, it's really helpful, but I'm going to try just attack V. There we go. That's a little bit cleaner. This is more what I was looking for. So here's our stack strings, and here's where all the matches are. The 6.9, that must be the base address for the shellcode. Maybe it's the default image base. I'm not sure. I didn't actually look into it. I just made the assumption because I know that at offset E5D, that's the entry point. So it would just make sense then, based off of my understanding of the shellcode, that it must be based at the address 690.0.0.0. Now, let's see. Let's do this. If we want to analyze the shellcode, and I want to do it in IDA because I'm just an IDA user, I have the free version of IDA, and I can't just open this blob of shellcode with IDA, right? If I right-click and say open with IDA, because I'm on the free version, here you go. There's your information. This version of IDA can only disassemble PE files. So it's kind of annoying. One of the reasons, actually the main reason that I was motivated to create SC Launcher was for this little obstacle here in terms of training. And this is also available in the Flare VM. What I want to provide it with is the stage 1. Okay, so stage 1 underscore shellcode.bin. So the path to our shellcode data in a file. And if we use the -PE option, this will create an executable version of the PE shellcode. This will create an executable version of the shellcode, just simply wraps it in a PE file, puts the shellcode into a text section. Okay, I wanted to find an output file, so I'll just call this shellcode.bin. And now we should have shellcode.bin. We could run Capa again. We'll get the same results, so I won't do that. But the main thing I wanted to show you now is that if we right-click and open with IDA, let's see, now we have the ability to analyze that shellcode. So easy way around it. Let's go back. Of course, with the tool, shellcode launcher, I have it clear the terminal output. So we got to start this analysis over again just so I can get those offsets. That's mainly what I wanted to do, and show you now that we can kind of quickly pivot using these locations here to find stack strings. So 10A0, that's our offset from the base, 690000. We just want the raw offset from the beginning, 10A0. I said this just gets put in a text section, so the location will be 401000, the default image base plus the text section at an offset of 1000 hex. So we just have to add the two. We can jump to address 4020A0. Let me just confirm. Yep, 10A0. So there we go. There's just a G shortcut key. Jump to that address, and you can see there's our stack strings. So while IDA didn't necessarily disassemble this, there's probably something up here. Maybe this just get converted into a function. Let's see. Yeah, I bet that's it, right? There's no function definition here by IDA. We could probably do that, create that function. And now we'll just jump back to that location again, 4020A0. And there you can see. So likely that was a basic block scope. And there it is. So now we can right click and convert these to ASCII, or just use the R shortcut key. And I'll zoom in here so you can see that. There's our stack strings. And so those are helpful because they're hiding a string. Now, a tool like Floss understands stack strings, so Floss can unravel those, but hopefully you get the idea here that using something like Capa not only helps to give you that high-level extracted capabilities, but it can also help you to quickly identify things when you're analyzing that binary code itself. So really helpful. Something I forgot to point out, just to rewind for just a second, is there was no detection for this XOR in this XOR loop. So I'm curious about that. I didn't have the time to dig into it here before the stream, but that would be something, if I kind of have that forehand knowledge and then it's missing in the capabilities extraction, I'd want to look into it. And the project is open on GitHub. If there is a way to create a new rule or improve the rule or whatever the case may be, maybe it's just a really bad implementation by me, that would be a great opportunity to contribute to the project and improve the tool for future use. So I did want to point that out before I forget. Okay, well, that's our shellcode. Let's look at another steal C. This is a stealer. We'll just do a basic Capa here, steal c.bin, see what kind of extraction results we get. Now, this program here, this one has a little bit of anti-disassembly, a little bit of anti-analysis, but it's not packed. And so you're going to see that you're going to get kind of a mixed bag of capabilities that are extracted here. For a stealer, you probably would expect more capabilities, and I certainly would. And so the output's going to show that there's something going on, but there's not an upfront layer of packing. And so it just is going to probably mean that in order to really understand what this stealer is capable of, we're going to have to get in here and do some reverse engineering. Things like, or capabilities such as base64 strings, XORing, RC4, that's a really good one to detect. That is then a pretty good indication that, well, maybe not it's packed, it still has obfuscated data, string data, maybe additional code that it's deobfuscating or decrypting on the fly. And so identifying this can help to begin to unravel that. Let's look at this one as well, because I will say firsthand, being able to have a quick detection for things like RC4 can be really helpful, because the algorithm is quite straightforward. The implementation is rather straightforward. But it's easy, it's been easy for me over the years to get lost in the analysis and not recognize that I'm looking at RC4. And so to have a signature point that out for me just makes it that much quicker, and also helps me to avoid not recognizing it myself and then wasting time trying to figure out what kind of encryption, or maybe I don't even recognize this encryption. Maybe I'm still trying to figure that out. And that's gotten me in the past where I just got so lost in this really complicated binary, I didn't take a step back when I got to a certain stage and use something like this to help me recognize that. So let's see here. We've got RC4 function. So it's at a function scope. And here's our address, 402 EFA. So again, we can just jump into IDA. Let's see, steal c.bin and open with IDA Pro. Okay, this one has some anti-disassembly I mentioned earlier. We won't have time to get into a lot of what's going on here, but you can tell if you recognize jumps like this is usually a tell that it's doing opaque predicates, and the fact that this just devolves into gibberish after, that's a good indication there. But don't need to worry. 402 EFA, that's where we want to go. So I'm going to G shortcuts key 402 EFA. No, that was the wrong one. 402 EFA. There we go. And so this is what it's saying, that this function is RC4. Maybe a little harder to tell when you're analyzing it with the disassembly view here. So if you've got the decompiler, this is the latest version of the free IDA. So you can hit the function F5 key, and it will give you the decompiler results here. It'll use the cloud decompiler. So there's some data going to Hexrace. You've got to be a little careful with that. But the gist of this is that you can, you'll recognize the pattern, and you can go, oh yeah, this really is RC4, because we have things like the key scheduling algorithm. But you look for a couple of loops, and the loops will be mod 256, and that's a pretty good indication. If you don't know, or if you're not confident, look up implementations of RC4. Wikipedia, for example, has a good code sample or code snippet. You'll find example RC4 in C on GitHub projects, or just files that are posted there. That can help you. But if you don't recognize the structure, and usually you do once you know what to look for, having something like Capa point this out for you right away. And of course, you can use the integration with IDA and Ghidra, and that'll help as well. So that'll be really helpful. So and again, allowing us to get right into it, and specifically looking at where this occurs in the binary. So we can go from kind of the high level capability to very discrete if we need to. Okay, what else do I have here? Let's close these IDAs just so I don't let them allow me to get distracted again here. Okay, a couple more samples, and then that'll be it. So I wanted to get, actually this is the last sample. Okay, so there's our last sample. I have two here, but they're kind of similar in terms of the demo that I was aiming for. The first one here is snake keylogger. This one is already unpacked. Oh, actually, you know what? I do have two. That's right. I need to show the sample here. So let's go back to our actual Monday sample. So this has been the sample that has sort of persisted throughout the Malware Mondays. And this one we will eventually get to unpacking and more detailed analysis. But for right now, we're using some of these basic tools to help. Now, this one, I don't know if we've come to the determination that it's packed or not yet. I think we have, because we've done some of the basic analysis. For example, we've looked at strings, very little strings. We would do dynamic analysis, and I think we did some strings in memory, and there were ample strings, or maybe not strings, but we saw network activity. We saw HTTP posts and GET requests, and we didn't see evidence of those strings that support that HTTP request, such as the headers or the domain or URL. So we know that it's packed. Here, Capa is also saying this file appears to be packed, and it's using some internal packer file limitation rules in order to in order to give you some indication that you can't really rely or maybe even trust the output here. In fact, if you really wanted to learn more, you'll have to go into those verbose modes to help. If we want to look at some of those internal rules, I'm going to go back to that rules repository. And I just made a guess here that there was an internal, and there is an internal. And here we have internal packer file limitation.yaml. And you'll see that there is this feature. So the feature is going to be where the detection logic occurs. This match keyword just allows it to match on other rules. So this means that now we have to go and look at anti-analysis packer. So I'm going to just navigate here in the repo to anti-analysis and packer. And now we have all these rules. Right. So something in here was matching. I'm curious. I guess let's do -v on the sample just to see if it'll tell us exactly what rule is the culprit. I have my theory already, but just give that a second here. No, I don't believe Capa does any unpacking for you. I think it leaves that up to you or another utility. So it's just going to take the file, disassemble what you give it, and then unless something matches like you see here, that's all it's going to do. Now keep in mind, Capa has integrations with sandboxes like Cape, so you might be able to get to a point where it's analyzing memory dumps. I haven't really used Capa with any sandbox yet, so not entirely sure how it works, but that could be a way around it where now the sample has ran in a sandbox, it's reached a state of unpacking, maybe a memory dump is dropped, or I don't know, however the sandbox is capturing information and then feeding that into Capa to get your capabilities. You can see this is taking a little bit of time here, but we prompted it, we told it to go a little bit deeper. Anyways, if I just let's look at Amadei in Detected Easy. And all I really want to do is look at the sections, because here we have mpress and mpress2. Oh yeah, that's right. So maybe there's a rule that has mpress. Let's just see. No, I don't see one. So I guess I'm not entirely sure what it's matching on. So I'm interested to see what the result is and if we can make any sense of it here. Maybe there's an mpress. I was thinking it was Themida. I must have looked at a different sample recently that had Themida as its packer. And Themida has, quite simply, here's the rule, packed with Themida, section names that use Themida or some other different Win license. It looks like Win license, Win lice. All right, that's what I was thinking. So I'm not entirely sure what it's matching on, but we'll give that a minute. Oops, we'll give that a minute or so here to analyze. As I said, sometimes the analysis can take a little bit of time, so you just have to start it cooking and come back in a bit. The last sample then is the snake keylogger, and we'll get the output here in just a moment, but I wanted to, again, kind of connect the dots with this and some decompilation in dnspy. So let's jump ahead to get dnspy open. dnspy, if you're not familiar, it's the go-to for decompiling .NET. There was a recent release. You can see I've got my VM connected to the internet, so it's telling me up here that there is an update that you can download. I don't have that update. But it is the go-to. Definitely check out the project, support its work if you use it for .NET disassembly or decompilation. I'm going to take this sample and just drop it in, open it up to expand the project. And one of the first things that I notice is that we have these obfuscated symbols or these strings. This just looks like Unicode characters, and it's nonsensical. And so that's a layer of obfuscation that, oh, I guess my terminal's all tied up. So I'm going to open up another one here. And let's go to the desktop and DE4 dot. Right. It's an old tool. It's not been maintained in a while, but I find that it is still really helpful. We can just give it the binary that we want it to try to deobfuscate for us and define a new output file. I'm just going to call this snake cleaned. And hopefully this works, right? So it says it's cleaning it, renaming all obfuscated symbols, and now it saved the file for us. So now if we go back to DNSpy, I'm going to close this, right-click and remove, because I don't want to confuse any of my analysis here. We can now take the cleaned version, drop it in, and you'll see that the strings and the symbols are going to look quite a bit better. Going to be a lot easier to investigate this binary. Now, this is unpacked, but there's still obfuscation, as you just saw. And normally, if I were to begin this analysis, I'd probably just go right-click, go to entry point, and see what's happening at the entry point. And you'd see here, well, oh, there's a bunch of methods that are being called, and it looks to be quite noisy. So, something like Capa can really help. Let's see if this is done. Oh, it is done. Okay, so let's finish this train of thought here. Something like Capa can really help. So I'm going to run Capa with the first verbosity level. Capa snake cleaned. Let's let that run. Shouldn't take too long. Oh, you know what? Actually, let's just terminate that. Let's first just take a look. See, I did get a little bit ahead of myself. But let's just first take a look at Capa output. There's two things I want to do here. There's one is to use the filter option, and then two is to correlate activity capabilities with the decompiled code. So, all right, so here we go. We're getting some analysis, and yeah, ooh, boy, lots of stuff. Let's see if I can shrink this just a tad. Okay, formatting is going to be a little hard to read here, but you can see there's a lot of capabilities that were extracted. So also a good sign or indication that it's not a packed binary at this point, which it's not. Here we can use the filtering. So let's say I'm just really interested in, I think this is a stealer, I know it's a stealer, what is it stealing? We can use the -T. Yeah, my terminal's all messed up now. Let's see if I can get out of here. And provide it with the value essentially that we want to filter on. So I'll say collection. That'll hopefully provide and look for things like the namespace that has the word collection and narrow our results to just information potentially that it's stealing. So this looks a lot better, right? Get geographical information, save an image in .NET, keystroke logging, screenshots, right? We have these capabilities. We can take this now one step further. And the reason that I wanted to get into DNSpy for just a few minutes here. Question was, what OS am I using? I'm using Windows 10, and it's the Flare VM. So for most of my Windows-based malware analysis, I'm in a Windows VM. I haven't made the jump to Windows 11, but I would imagine it's not too terribly painful. Usually the reason that I don't is once I get on a system and I get things working and I'm happy with it, I don't like to jump ahead because I don't want to have to spend a lot of time reconfiguring tools and how they work. The reason that I stayed on Windows 7 for a long time before jumping to Windows 10 was the same reason. So now that I'm on Windows 10, I'm hoping to stay here for a while just because it works. I don't see any reason to jump into a Windows 11 VM at this point. So Windows 10, Flare VM. I'm not sure. You'd have to check the Flare VM repo to see if they support Windows 11. I would imagine they do at this point, but they probably have information there on like the suggested, recommended, required version of Windows or supported version of Windows that the install scripts work on. Okay, so let's say that we wanted to look at the keystroke logging as an example. You'll see here's just the slightly more verbose information. It's a function scope, and it matches on this token. So with .NET, not to get into all of the gory details, but there's a little bit, it's a little bit different. Like with the executables that were native code, all we needed to do is get the address, open that up in IDA or Ghidra, go to that address, that's it. This is a little bit different because you have these tokens, and I'm going to copy that token right there. So let's go back because I didn't want it to do that, but it did. 600,000A2. In order to understand where that token resides, there's a little bit of background that can be helpful. So back in DNSpy, you can open or expand this PE tree. See this up above here. This allows us to explore the PE file. We could use another tool like CFF Explorer, PE Studio, Detect It Easy to get some of this information too. But there's these streams. you see down below here. And this first stream, the tilde, I've forgotten what it's called, but it has this table stream. And essentially those tokens are there's like two parts to the token. You have the token, the first part that tells you what type of token it is, and then the second part what tells you the index. And that first part's going to reference a table. So 06 is our methods. So if we expand that, then the index is A2, which unfortunately the indexing here is in base 10, not hex. I did the conversion earlier. I believe that's 162. But you can do that conversion, and so that would mean that our function that we're referencing here is this VK code to Unicode. That's what it's called. So why do we need to do all that? Well, we don't necessarily. I just wanted to provide a little bit of the why does this and how does this work. To jump to a token in dnspy, you just do Control D. There's our metadata token. Oh, yeah, I didn't get it copied. So 0x600000A2, and it will turn not red when it has a valid token, and now it should just navigate us right to that location. And there it is, VK code to Unicode. So that's essentially how you jump directly to the function based off of the results from Capa. And now we can analyze it. So we get keyboard state. Oops, go back. Didn't mean to click on that. Keyboard state, map virtual key, get foreground window. I don't know off the top of my head if this is how to log keystrokes with .NET, but it sure looks like it to me. So now you could do some analysis here if you needed to in order to understand. Maybe you don't care necessarily about exact APIs that it's using to do that. Maybe you do. Maybe we just want to figure out where is it logging those keystrokes to. Is it writing them to a file? Is it just keeping them in memory and then eventually flushing that and sending it to a C2 node? Right? Like now our analysis can become quite a bit more focused. And as you look here to the left, I mean, there's just a lot of methods. A lot of them, when they got renamed, just get default S method 20, 21, 22. Like, we don't know what those are. And I surely don't want to have to go through these one at a time. Of course, another approach is to go back to main and just start analyzing from main, but that can take a long time. So you can see where Capa can really help, not only high level, but also at a very kind of tactical level to give us this information. Okay, so that's how you can do a little bit of mapping there and filtering and just getting that initial, what is this binary up to, help me, with some triage and then maybe even some low level. And so again, even if you've gotten a sample and you get to the point where you've got it unpacked, it probably is worth going back through and running Capa again. The new last thing is just seeing if we have, let's see, we've got some matches here. Packed with mpress. Oh, there. Okay, so there was an mpress. Anti-analysis packer mpress. So this tab, if you recall, when we tried to run the Amadei sample against it, Capa said, nope, it's packed. I don't think we should do this. We prompted it, though, to give us matching information. So here's matches that resulted from prompting it to run. And this is probably the core of it, this anti-analysis packer mpress. So we'll go back to the rules. Anti-analysis packer. So somehow I looked right at it. Oh. Okay, I'm not sure what I'm missing, but it's obviously in here somewhere. Anti-analysis packer. Maybe I'll just type it in. Yeah, page doesn't exist. Okay, so I'm not entirely sure where that lives. I'm sure, though, with enough digging, we'd be able to find it. Maybe it's just obvious and right in front of me. Maybe it's a little bit more tucked away somewhere, but it's likely in here. Probably the easy button at this point would be just to search. Maybe I download the repo, put it into Code or Studio, and just search for mpress. I'm not really entirely sure, but we could, again, this just allows us to investigate a little bit further if we need to try to understand, like this, likely there's another tool out there that would tell us that it's packed with that. For example, detected easy. I think we already saw that, right? And let's just look at it again. Detected easy. Yeah, see, it's telling us it's mpress, but this might be another way, though, just to get if Capa's telling us something is packed. well, how and why? What is prompting it to tell us that? This would allow us to look and maybe give us some much needed information about the type of packer. Maybe, maybe not, right? It's just another resource, another potential source of data to help with your analysis, to help you determine current state and what your next steps could or should be. Okay. Programming Walla, thank you. I'm glad that you joined. That's all I have for the analysis here, just under an hour. So I guess that's kind of the new norm, kind of like teaching a class. I got an hour or 50 minutes and right at time. So that's good to do, good target to hit. Any questions, let me know. I know there's just a little bit of delay here with the using OBS for stream and you all receiving the actual video audio here, but yeah, backtrack is definitely the easy button when you're navigating. So let's see here. We've got up on the top here, if that's what you're referring to anyway, Ken. I use this a lot. Forward and backward navigation, much like in IDA. You have the escape key to go backwards in your history. So if you click on something and you end up in a library function, for example, I didn't want to be here. I usually hit escape and then realize, oh, I'm in DNSpy. I'll go up here and I'll click the back button. So yeah, next week, I don't think I have it up, but let me just promote this real quick. We've got the next live stream. It's not going to be a Malware Mondays, but it is going to be a live stream with two of the folks that I'll be doing one of my DEF CON workshops with. So Ryan Chapman, SANS instructor, Aaron Roseman, longtime Pluralsight author and director of security content, I think, a director of something, and he's very much in the security domain. So please consider joining that next week. I want to try something a little different, have some informal streams here. We're just going to get together, talk about, kind of what goes into, how we write the proposal. How did we come up with the topic? How do we prepare? And maybe the surprising amount of information that you have to cut in order to, fit the content into a 1 hour live stream, or in this case, a 4 hour workshop. So definitely check it out. I'll be in Vegas then shortly after that for Black Hat and DEF CON, and then a little bit of vacation. So the live streams might be a little sparse here between now and the end of the summer here in North America, but do my best to keep those going. So appreciate everyone subscribing and joining and engaging here. But if there are no further questions, then I think it's time to wrap things up. So I'll hang tight for just a few seconds and then end the stream. Thanks, everyone. Hope to see you next week at the next live stream.